Hello once again. So we're going to be looking at question 2 now, which is also another business valuation question. So without wasting much time, let's get into it. So Mukuba Group has a 12 million kwacha face value bond issue outstanding. The issue carries a coupon rate of 10% with interest paid quarterly. The issue matures in 3 years. What is the value of the bond issue if it is priced to provide a yield to maturity of 12%? The issue matures in 3 years. Therefore, what is the value of the bond issue if it is priced to provide a yield to maturity of 12%? So how exactly are we going to solve this? Let's collect the data. So we've been given here to say that our first value, which is we are going to denote by FV, it's not future value, but our first value, FV here, is what? 12 million. So we're going to write 12 mil. If you're confused, 12 mil or 12 million is just simply 12 and 6 zeros. This is how it looks like. Yes. So 12 mil or 12 million is our first value. And then the question goes on to say that the issue carries a coupon rate of 10%. So our coupon rate, which we're just going to say coupon rate, is equals to what? 10%. And the interest, right, on this coupon rate is paid what? Quarterly. So the coupon rate is paid what? Quarterly. So payment of interest is paid quarterly, which is just 1 over 4. So the payment of interest is paid quarterly, right? Then the issue matures in 3 years. So the number of periods is basically 3 years. So NT, whether you use N, the letter N or the letter T, time periods or number of periods, honestly, it's just one and the same thing, right? But you see in the formula, we're going to actually use both N and T, but they just mean the same thing. So number of periods here is going to be what? 3 years. What next? The question now goes on to say, what is the value of the bond issue if it is priced to provide a yield to maturity of 12%? So this bond, once it matures, it needs to provide a yield or return of capital of 12%. So our cost of debt, which is our KD, our cost of debt in this case is what? Is 12%. So when the bond matures, when paying back the money, there should also be a 12% what? Return, right? To us as the company, as Mukuba Group, this is our cost of capital, right? This is our cost of what? Of capital. So let's go ahead now. Now that we have our data here, let's go ahead and answer the question. So we have our data here, and you know that our formula for calculating the valuation of a bond, remember that the previous question we were calculating the value of what? Of common equity. In this case, we're calculating the valuation of a bond. So we know that the formula of a bond is just going to be equals to V equals 1, or I rather, which is the interest rate, the coupon. Remember? The coupon that is paid quarterly at 10%. Yeah, this is this guy here. Our I is equals to 1 plus KD to the power T plus MV divided by 1 plus KD to the power what? To the power N. You see, we're using T here, we're using N, but literally they are just one and the same thing. But remember that this formula, if we use this formula, it's going to take us a really long time. Sorry, this is our V, valuation of a bond formula. But remember, if we use this formula, it's going to take us a really long time. So we need to use something that will be much similar or much simpler. Sorry, we need to use something that will be much what? That will be much simpler. And that is using the present value interest factor annuity and the present value interest factor table method, right? So our valuation of a bond is going to be equals to our coupon right here, which is our interest, multiplied by our present value interest factor of an annuity KD, comma, N plus our maturity value multiplied by our present value interest factor. Not annuity, just present value interest factor, KD, comma, N. That's that. So this is a formula that we are going to use to calculate the valuation of the bond. We could use this one, but remember that this one will take us a lot of time because remember, for this part, we have to do it for each year. So we're going to have the coupon here divided by this to the power 1, again another 1 plus this 1 plus KD to the power 2, 1 plus KD to the power 3, and then eventually add it together with MV divided by 1 plus KD to the power what? N. So doing that is a whole lot of a process, but why do all that when we can just use the table, the present value interest factor tables for both an annuity and just for uh, an ordinary bond or ordinary asset. Okay, so this is what we are going to do, or this is what we are going to use. But remember that our question here says that what? Payments of our interest or our coupon is paid what? Quarterly. So we're going to have to modify our formula to show this quarterly payments. So to modify our formula, we're going to say V is equals to our coupon there, which is being paid what? Quarterly. So we're going to divide. Remember how many quarters are in a year? 4 quarters. So we're going to divide this our coupon by what? By 4. Or interest by what? By 4. This is I, by the way, right? And then we're going to multiply everything by what? Our present value interest factor of an annuity. Why are we saying annuity? Because this I, or this coupon, we're going to be paying it for each year. And remember that it's coming at a rate of 10% of the face value. So it's going to be the same throughout the 3 years. So it's a same stream of cash flow for each of those 3 years. So this is why we're using an annuity, because remember what the definition of annuity is? A stream of cash flows that are the same, occurring over a certain period of time. A stream of cash flows that are the same, occurring over a particular period of time. So our coupon here is going to be the same throughout the 3 years. So this is why we're multiplying it by what? The present value interest factor of an annuity. And then our KD here, our cost of debt. Remember our 12%? We're going to have to divide it by 4 as well, right? Because we have to convert it into quarterly what? Payments as well, or quarterly cost of debt. So it has to be quarterly as well. So our 12%, which is going to be our discounting factor in this case, is going to be what? In quarters as well. So we have to divide it by 4. And then for the number of periods, which is our T or N, we're going to have to multiply it by what? By 4. So 4 times N. So that's what we're going to have for the first part there. And then for our MV, we're just going to have MV there. And then we're going to have our present value interest factor. So remember that our MV is just 12 million. It's just one cash flow. So there's no need for us to use the annuity discounting factor. We need to use the what? Just the normal present value discounting factor, because this is just one stream flow, one stream of cash flow, which is not, it's just one, it's a single stream of cash flow. So we just need to use the present value interest factor. That's that. And then for our KD as well, it's just going to be divided by 4 multiplied by 4n. That's that. This is how we're going to do it. All right. If this is how we're going to do it, then let's figure out what our I divided by 4 is, our KD divided by 4 is, as well as our 4 times n. All right, let's figure these guys out. So to find our coupon, which is our I, we're going to say face value multiplied by what? Multiplied by our coupon rate. So we know that our face value is what? Is 12 million. And if we look at our data here again, our coupon rate is what? Is 10%. So if our coupon rate is 10%, we're going to multiply our face value by 10%, so that we find an I, or our coupon, of how much? 12 million times 10% will give us 1,200,000. So it will give us 1,200,000. This is our coupon, or our interest that we're going to be making each year, or that we're going to be paying each year. So this 1,200,000 is our interest that we're going to be paying each year until our bond that we've issued matures, right, at the end of 3 years. Remember that our question here says that payments are what? Interest payments are to be paid what? Quarterly. So we found our I, which is 1,200,000. So we now need to find the payments of this 1,200,000 that are going to be made quarterly. So this is a yearly payment. We now need to convert this yearly payment into a quarterly payment. So to do that, we're going to just do this here, what we have here. So that's going to be I divided by 4, and we're going to have our I on top there of 1,200,000 divided by what? By 4. Since we're dividing this by 4, we are going to get a new quarterly coupon payment of how much? Of 300,000. So this is going to be our what? Our quarterly interest payment, 300,000. So we found what our coupon is to be paid quarterly. Then what else do we need to find? So we found this guy, which is our I divided by 4. Now we also need to find our what? Our KD divided by 4. Our cost of capital divided by 4. Our cost of debt divided by 4. So KD divided by 4 is just simply 12% divided by what? Divided by 4. So 12% divided by 4 will give us how much? Will give us 3%. So this will be our new cost of debt quarterly, right? We are converting this. Remember that this 12% is a yearly cost of debt, right? That much that we are going to, that must be yielded at the end of the 3 years. So, but we need to turn it into quarterly, all right? So when you convert it into a quarterly cost of debt, it will give us 3%. Now that we have the 3%, we need to now find our n times 4, or our 4 times n. So we know that we're going to have 4 here multiplied by what? By n. What is our n? 3 years. So 4 times 3, that will give us how much? That will give us 12. 12 periods. So these quarterly payments of 300,000 kwacha are going to be paid within 12 periods within these 3 years, right? So 4 times 3 equals 12. Now that we have our periods that are equal to 12, we have our cost of debt that has been converted into a quarterly cost of debt of 3%, and we also have our coupon rate, which has been converted into quarterly payments of 300,000 kwacha. We can go ahead and now find the what? The value of this bond. So in order for us to find the value of this bond, we're going to say V is equals to what? So let's look at our formula here. V is equals to the coupon divided by 4, which is quarterly, and we know that our I divided by 4 is what? Is 300,000 kwacha. So our I divided by 4 is 300,000 kwacha. That's what we're going to put there. Okay. Then we need to find our present value interest factor of an annuity. So when we go to our table, so we're going to go down to where 3% is, and you know that our number of periods in quarterly form is what? 12 periods. So we're going to go to 3%, and then we're going to go down to 12, right? When we go down to 12 at 3%, we're going to find a discount factor of an annuity of what? 9.954. Of 9.954. This is going to be our discount factor of an annuity. Remember, this is an annuity because this 300,000 kwacha is a payment, interest payment we're making quarterly for all of the 3 years. So it's a cash flow that's going to be consistent throughout a longer period of time, or a particular period of time, a specified period of time. And so it's an annuity. So we multiplied by our present value interest factor of an annuity, and then we're going to add it to our maturity value, our MV. See how our formula looks like. Our MV here, what's our MV? Our MV is 12 million, which is basically our first value. Our maturity value is 12 million. 12 and 6 zeros. This is our maturity value. And then we need to find our present value interest factor, because this 12 million is just a single cash flow. So we don't use an annuity factor. We need to use a single present value interest factor. So to do that, we go down to the table for present value interest factor. Just for the present value, not the annuity, the present value, please get me correctly. Again, remember that we converted our cost of debt to what? To 3%. So we're going to go down to 3%. And then when we go down to 3%, we are going to go down to what? 12 periods. Our periods have also been converted into quarterly form of 12 periods. So we're going to go down to 12. So 3% down all the way up to 12, it will give us a present value interest factor of 0.7 or 1. 0.7 or 1. Okay? Once we have that, we can now start calculating to find the valuation of our bond. So it's going to be 300,000. 300,000 times 9.954. That will give us what? 2,986,200 plus 12 million multiplied by 0.701. That will give us a present value of 8,412,000. So the present value of our maturity value will be 8,412,000. The present value of our annuity payment, which is 300,000 kwacha, will be 2,986,200 kwacha. Will be the present value of our what? Of our annuity payment of 300,000 kwacha. So all we have to do now that we found both these present values of our annuity and of our single cash flow, which is our maturity value, we can add the two of them. When we add the two of them, what are we going to get? We're going to get a valuation of our bond worth 11,398,200. We're going to get 11,398,200 kwacha. 11,398,200 kwacha as the valuation of our bond. So the value of our bond is 11,398,200 kwacha. And just like that, we have answered the question, and you would have gotten your marks for answering this particular question.